morning, students. Today we are going to discuss measurement further. Let me share the objectives of today's lesson with you. Describe an estimated length of smaller and larger objects. It means we will discuss some objects smaller in size and larger in size. Identify appropriate instrument for measuring certain lengths. You will be able to identify that for smaller lengths we are going to use some smaller instruments, and for larger we are going to use other instruments. Name different parts of Vernier calipers. Vernier calipers is an instrument which is used to measure small diameters. Then we will practically measure the diameter of marker with the help of Vernier caliper. List and mention least count of instruments. We will discuss least count as well. Now the scale of things, or miniature to gigantic, means from smaller objects to larger objects size wise. These are few examples taken for you. The radius of hydrogen nucleus is of the order of 10 raised to the power minus 15 meters. Size of an atom is bigger than the radius of hydrogen, and that is of the order of 10 raised to the power minus 10 meters. So the atom is definitely larger in size than its nucleus. That is, suppose that if this is nucleus, then the size of this is 10 raised to the power minus 15 meters, while the overall atom is bigger than its nucleus. Suppose this is atom. The diameter or the size of the atom is larger than the diameter or the size of the nucleus. The diameter of wire, suppose it's a thin wire, copper wire for example, the diameter is approximately 10 raised to the power minus 3 meters, which can be written as 0.00 meters as 1 meters as well. So this is approximately the diameter of a thin wire. Length of a 4 size page of your notebook's page or the printer page is 10 raised to the power minus 1 meter approximately. The diameter of Mariana Trench is nearly 11,034 meters. If you divide by 1000, that is nearly 11 kilometers, while the height of Mount Everest is 8,848 meters, that is nearly 8.8 kilometers. Mariana Trench is a popular place in ocean, and that is the deepest point in water. If you put Mount Everest in Mariana Trench, it will disappear in it. Radius of Earth is 6.4 into 10 raised to the power 6. It is 10 raised to the power 6 meters, or that is equal to 6,400 kilometers. So these were smaller objects and larger objects. Now the instruments used for measuring different things. For example, if I ask you name instruments to measure the following: how to measure the length of the room, definitely your answer will be measuring tape. If you observe measuring tape, then this length is 1 centimeter, and the small marks, these are millimeter. So 1 centimeter is equal to 10 millimeters. So these marks are of this 1, 2, 3, 4 and so on. It shows centimeters, while the smaller marks are millimeters. So the smallest thing or a reading which we can take on this is 1 millimeter, and that is why we say that the least count of this is 1 millimeter, means the least possible value which we can measure on it is millimeter. The height of table is measured with the help of meter rule, or in daily life we call it meter rod. Diameter of whiteboard marker or suppose it's a small steel ball and you want to measure the diameter, then we can use vernier caliper for it. This is the vernier caliper. The thickness of wire, assume that it's a copper wire, we want to measure its thickness, so for this purpose we use micrometer screw gauge. So these were the few instruments which are in your chapter for measuring lengths, that is measuring tape, meter rod, vernier caliper and micrometer screw gauge. Now what is meant by least count or precision? Least count is the smallest possible unit an instrument can measure for you. It's called least count. It means that, like I described over there on the measuring tape, that the smallest reading we can measure, and it is millimeter or 1 millimeter. So the least count of this instrument is 1 millimeter. Similarly, we have instruments. The table given shows measuring tape or meter rod. The least count is 0.1 centimeter or 1 millimeter. Vernier caliper is having least count of 0.1 millimeter or 0.01 centimeter. Micrometer screw gauge is having least count 0.01 millimeter, or that is equal to 0.001 centimeter. So this instrument can measure smaller object like thickness of wire, while this one is able to measure bigger object. Now you can see the difference over here in these two. It means this can measure 100th part of millimeter, while this can measure 10th part of millimeter, while this one is 1 millimeter. So these are least counts of different instruments. Now when we do experiments and measurement, we cause errors. What is an error? That is nothing but the difference between two things. The difference between right and wrong, the difference between actual value and calculated value is called an error. For instance, if a mathematics teacher asks you to calculate 2 plus 2 into 2, definitely what you will do, you will write 2 plus 2 into 2 is 4, and that gives you 6. So the required value is 6, while the value which you have calculated is also 6. Both are equal, so there is no error in it. But if you add 2 and 2 first, that will give you 4, and then you multiply it by 2 in the end, that will give you 8. So the actual value or the required value is 6, while the value you have calculated is 8. So there is difference in it. Both are different from each other. So there is an error in your work, and I call it the difference between the correct value and the value which you have calculated. Errors are caused by persons doing experiments. Error may be due to an instrument as well, and error may be due to some other reasons, like the changes in environmental parameters, like the changes in voltage or the temperature of environment. On the basis of this, we can say that list of common causes of errors are: no skill, means a person is doing experiment but the person don't know how to handle or perform the experiment with the help of the apparatus provided. Similarly, for example, the person is skillful but is careless, and error will be caused. Sometimes the person is skillful, careless, but the instrument is not accurate, or it is faulty instrument, it is wrong calibrated, or the marks are worn out, so the error will be caused. The different types of errors which we will discuss in this chapter are: personal error, The error caused in measurement by a person doing an experiment, and the person causes experiment due to lack of skills of using and handling instruments or carelessness. Usually an experimenter or students, they cause an error called parallax error, which we'll study further. The next is systematic error. It is an error occurred in measurement due to faulty apparatus. For example, zero error. Or it is an error caused due to incorrectly calibrated instrument. That is why we call it the error in the system or the error in the equipment. Then there is random error, which is an error caused due to unpredictable changes in environmental temperature or voltage, etc. Now, what is parallax error? It is an error caused by a person when the eyes are not positioned perpendicular to the rule. For example, if I want to measure the length of this block, my eyesight should not be like this, nor like this. These are the wrong positions of the eye, and this will cause an error. You can see here, if you position your eye here and you look here, so you are reaching here, which is incorrect. The correct point is here. Similarly, the correct position is here, and if your eye is here and you are looking in this direction, so you will reach here, which is wrong. If you want to calculate the length of this block in this situation, then it will be 4.123. So this end is 4.3, while the other end will be 10.5 nearly. So this is 10.5. So it is 10.5. Then what we do, we subtract, sorry, it's 10.5. So we subtract 10.5, 4.1. 10.5 minus 4.3, that gives you 5 minus 3 gives you 2 point, and 10 minus 6 gives 10 minus 4 gives you 6. So the length of this block in this situation is 6.2 centimeter. This ruler is calibrated in millimeters. The small units are millimeters, but this is 1 centimeter, 2 centimeter, 3, 4, and so on. But if you avoid this error, how this error is caused? It is caused due to wrong position of your eye. If you correctly align your position perpendicularly or normally to the site on the scale where it needs the reading to be taken, is this and this, then the correct answer will be what? This is nearly 9.5, slightly more than that. It's 9.5, while this is 4.5, 6, 7, 8, 9, and it's near to 5. So you can say, for example, this end is 5 and this is 9.5. So 9.5 minus 5 gives you 4.5, while here it was 4.3, which is wrong, and here it is 4.5. So 4.5 mean 9.5 minus 5 gives you 4.5, and over there it was 4.3. So there is an error caused of 0.2 nearly. This error is caused due to wrongly positioning your eyesight. So remember, students, your eyesight should be exactly perpendicular to the mark on the scale. This will avoid parallax error, and this error is very important for exams. Now there is another important thing. Sometimes the ruler which you use has this end broken down, so that will also cause an error. And sometimes the first mark over here is 0, so we say that on some rulers the 0 mark is exactly on the end. It is not in this case, but if the 0 starts from here and it is worn out and it is damaged, then this will cause an error as well. For example, if I want to measure the length of the block, and if the 0 mark is here, for example, and I put the block here over here and I want to measure it, and this end is broken, then it will be difficult for me to measure the length of the block with the help of this wrong dead end. So instead of putting the block here, you can put it somewhere here, like for example here, measure this location and this one and subtract this from this. That gives you what? The correct answer. Now there is another error in instruments, and that is known as zero error. So the previous error is a kind of personal error because the person is causing this error, while this error is the error due to faulty equipment, and that is known as zero error. This error will be discussed in the topic of Vernier caliper and micrometer screw gauge in detail. Now the topic is Vernier caliper. It is an instrument which is used to measure small lengths, for example diameter up to 0.1 millimeter or 0.01 centimeter. This is the least count of this instrument. Now let's discuss the different parts of this instrument. These two, they are called inside jaws, and they are used to measure internal diameter. For example, here is a small beaker and you want to find out the inside diameter, so you will use these jaws for it. These two jaws, they are used to find out the external diameter. If you want to find out the diameter from outside, not the inside, I mean this full diameter including the walls, then we use the outside jaws. So these are two sets of jaws, inside and outside. These two are used for external diameter, while these two are used for internal diameter. This scale is known as main scale, while this scale is known as sliding scale or Vernier scale. When we open the jaws of this Vernier caliper, this can be pushed in this direction. When this is pushed, this whole assembly moves in this direction. So this scale is sliding scale, or is called Vernier scale. There are small numbers on it which are marked here, like 0, 1, 2, 3, 4, 5, 6, 7, 8. They are up to 20 in this case. This thing, this end, is known as tail, or it is known as depth probe, and it is used for measuring the depth of a liquid. For example, that you want to see that here is a liquid in this container and how deep it is, so we dip it here. This can be taken out and put in it. We can find out the depth of this liquid with the help of this depth probe. Now what is least count of Vernier caliper? We discussed in previous slides that it is 0.01 centimeter or 0.1 millimeter. Simple method to find out the least count of the instrument is smallest division on a main scale divided by the number of division on Vernier scale. For example, the instrument given to you, that is a Vernier caliper, is calibrated in such a way that the smallest division on a main scale is 1 millimeter, and on the sliding scale there are 10 marks. So it is 1/10, that gives you 0.1 1 millimeter. Now zero error. When we do measurement, before measuring the diameter of something with the help of this vernier caliper, we close it. We close the jaws of the vernier caliper, and you can see it here. When the jaws are closed completely, we see there are two zeros. This zero, look, here is a zero and here is zero. There is a zero as well over here. It is for the upper jaws, so ignore it for a moment. There are two zeros here. This down zero is the zero of the sliding scale. We call it zero of the vernier scale, while this up zero, which is the mark over here, is the zero of the main scale. In this case, they are exactly aligned with each other, and when they are in this situation, we say that there is no zero error in it. But if I close the jaws of vernier caliper and the vernier caliper is rusty, and I am forcing it to close but it is not, then this zero will be slightly to the right of the zero of the main scale, and that will cause an error, and that error is known as positive zero error. But if I close the jaws and it is slipped, mean the zero of the vernier scale or sliding scale is slipped to the left of the zero of the main scale, then the error caused is known as negative zero error. So there are two types of zero errors. It will be discussed next. Now if zero of the main scale does not coincide with zero of the vernier scale, we touch the jaws of vernier caliper, then there is an error found in the vernier caliper called zero error. Before using vernier calipers, close its jaws, and there will be one of these three possibilities when you close the jaws. In this case, there was no zero error, but it can be negative zero, it can be positive zero error. So there are three possibilities. Possibility number one, zero of the main scale exactly coincides with the zero of the vernier scale. In such case, there is no zero error. Positive zero error. If zero of the main scale is a little to the right of the zero of the vernier scale, zero of the vernier scale is a little to the right of the zero of the main scale, like I told you here, that for example, if I have a faulty apparatus and that is closed, but still this zero is to the right as compared to this zero, so they are not aligned, then we call it the positive zero error. Positive zero error. Positive zero error occurs when zero of the main scale is here, it is on the left side of the zero of the vernier scale, or we can say that when zero of the vernier scale is on the right side of the zero of the main scale. You can say it either. So why this occurs? Basically, sometimes the instrument becomes rusty and you are forcing it but you can't close it, and it occurs when you put the vernier caliper in air or in some open place for longer time, so it gains rust and you cannot push it further, it can't be closed. So this much length will be an extra length, and we call it positive zero error. For example, in this case, how to find out how much error will be caused in our measurement, which will be in like an extra amount of length. So the method to find out this zero error is n multiplied it by least count, and as it is positive zero error, so here we write plus. What is n? N, you know the least count now. The least count of vernier caliper is 0.01 centimeters. What is n? N you are going to watch here on the vernier scale. This is vernier scale or the sliding scale. You are going to see that which mark or which number of the vernier scale exactly coincide with any mark on the main scale. So look, this 0 is not coinciding with any mark, 1 is not coinciding, 2 is not coinciding, 3 is not coinciding, 4 is nearly coincided as compared to other marks. So this 4 is coinciding, for example, exactly with this mark. You are not going to count this mark, you are going to count this one, the mark on the vernier scale, which is 4 in this case, for example. So 0, 1, 2, 3 and 4. This n is this 4. 4 multiplied by the least count gives you 0.04 centimeter, which is positive zero error. Means when we measure length with the help of this type of vernier caliper, in this vernier caliper there's a fault of 0.04 centimeter, which is an extra length, and this length should be subtracted from the final reading or from the final length in the end. When you subtract it in the end, you will get an accurate answer. Now negative zero error occurs when 0 of the vernier scale is a little to the left of the 0 of the main scale. Then there's a negative zero error. Look, in this case, this is the same 0 of the main scale, but this time 0 of the vernier scale is slipped to the left. It has crossed this actual position. So this much length will be an error, and this is known as negative zero error. And in the formula we write here a minus, so it is minus n into least count. And again the same method we apply to measure the negative zero error, but this time we measure the length, the mark from this end. So if you see, this one is not coinciding. 1, 2, 3, 4, 5, 6, 7, 8 is coinciding, but we are not going to call it 8. We measure from this side. It is 0, it is 1 and it is 2. So we write here 2 for n, and the least count is 0.01, so the error is 0.02 in this case, which is negative zero error. And this negative zero error is added in the main reading in the end. So the positive zero error is subtracted while the negative zero error is added. And remember the difference. This we measure the coinciding digit from this side, while this we measure the coinciding digit from this side. So a difference in both. Now let's discuss how to find out the diameter of whiteboard marker with the help of vernier caliper. So the first step is to close the jaws of vernier caliper and see whether there is zero error in it or not. So in this case both the zeros are coinciding very well with each other and there is no zero error in it. The next step is to see what is the least count. I told you in previous slides that to find the least count we see the smallest division on the main scale. So the smallest division on the main scale is millimeter or 1 millimeter, and then we see the total number of marks or division on the sliding or vernier scale. This is sliding or vernier scale, and if we see the marks here, look, there are 2, 3 up to 8, this is 9 and then 10 here. So but further it is divided into sub marks. So you can say that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 small divisions on the vernier scale, and smallest division on the main scale is 1 millimeter. So what we do, we divide 1 by 20 and we get 0.05 millimeter, which is written over here. This shows that the least count of this particular vernier caliper is 0.05 millimeter, or you can say 0.005 centimeter. So two steps here. Again, let me repeat. First check for the zero error and then check for least count. Now going further, the marker is stuck in the vernier caliper. Now here we read two readings. One is known as main scale reading, and the other is known as vernier scale reading. What is main scale reading? If you look here, this 0 and this 0, they were initially coinciding with each other when these two jars were in contact with each other. But when this marker is stuck in it, so they are separated from each other, the gap between this 0 and this 0 is known as main scale reading. And if you see till here, it is 1 centimeter. You can count this, and this is 1.1 centimeter, 1.2, 1.3, 1.4, it is 1.5, and this mark is 1.6. So we read till here, it is 1.6, it is 1.7. We do not take 1.7, we take 1.6. So main scale reading is 1.6. What about this small part? Don't worry about it. Vernier scale reading will measure it for you, and the formula for vernier scale reading is the same as like measuring the zero error, that is n multiplied by the least count. And what is n in this case? Let's here see, look, 0 is not coinciding, 1 is not coinciding, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is coinciding. So n is 14, and the least count is 0.005 centimeter. So the calculations are on next page. Here the diameter of the marker is main scale reading plus vernier scale reading minus the zero error. Here we wrote plus minus. If the zero error is positive zero error, we write plus zero error here. If it is negative zero error, we write negative. In our case, there was no zero error, so this part is gone. Later on we will discuss if there is zero error, what we will do with it. So this part is out, and the formula is main scale reading plus n into least count. N into least count is vernier scale reading. Or we can write main scale reading plus n into least count. The main scale reading in our previous example is 1.6 centimeter, which is here, this point till here it was 1.5 and it is 1.6. If you want to see it enlarged, so let me zoom it. So here till here it is 1, 1.1, 1.2, 1.3, 1.4, 1.5 and 1.6. This is main scale reading. And if you see the coinciding digit, it was here. So this 7 is coinciding, but this 7 is 14 basically, because there are submarks in it, which I told you earlier. So the formula is 1.6 is the main scale reading plus 14 is the coinciding number. The least count is 0.005. We multiply with each other, we get 0.07. With the main scale, we get 1.67 centimeter is the diameter of the whiteboard marker. So in this way, we calculated the diameter of the marker. Now let's wrap up what we have learned. Initially, we discussed lengths, smaller and larger, like the diameter of the nucleus and the radius of the earth, etc. Then we identified instruments for measuring smaller and larger lengths. Like for smaller lengths, for the diameter of smaller or smaller wire, like copper wire, we use screw gauge. For diameter of the marker, we used Vernier caliper, and for the length of the table, we use meter rod, and for length of the room we use measuring tape. This we discussed. Then we discussed different parts of the Vernier caliper. We will discuss screw gauge next, and then we calculated the diameter of marker with Vernier caliper, and we also discussed least counts. So that is enough for today.